The next section that we're going to look at is factoring and solving. They're not necessarily quadratics, but they have pieces to them that are quadratics. This is not a focus of calculus, but definitely factoring and using factoring as a tool to solve is something that shows up a lot in various problems. You know, you've learned how to do it a few years ago and it's come up again each year. At this point, the assumption is you know how to do it, you're comfortable with it, you can recognize it. It's not going to hold you back at all. And I know that's not always the case with students, so we're going to practice some of that factoring stuff. So if you look in your packet, it's on page 9. There's a few different methods of how to factor in there, and so and then also solving, although I know that's not as difficult for students. So first thing, there is a typo kind of in there. I do ask you to factor and then to solve problems if they have the little star thing. I'm calling it a star thing because I don't know how to pronounce the real word, which is asterisk. If you know how to pronounce that, text me, let me know. But it's supposed to equal something. You can't solve an equation if it's not an equation. These are all expressions, which means they can be factored, but they can't be solved. So for me to ask you to solve it, I really should have made it equal something. So this, I'm going to say equals 0. Number 5, you also have to solve. That should equal 0. And then the same thing for number 12. Go back and make that one equal 0. Okay. So we're going to go ahead and go through some examples of just some of the different types of factoring that we might need to review. So example 1, x to the third minus 25x equals 0. So one of the common types of factoring that shows up often is getting a greatest common factor out of the problem. And so this one, I'm going to do that first. I can see that I have a GCF of x because both terms have an x in there. And then once I take that x out, I have difference of squares. So I'm going to have two sets of parentheses, one with a plus, one with a minus. So that's definitely an x and an x. And then I have to think about the square root of 25, which is 5. And so x can equal 0, negative 5, positive 5. All right, for the second example, again, I have a GCF, so I need to take out the x from all three of those terms. And then from here I have a trinomial. It's not one of the simple ones because the x squared has a coefficient. So for this, I like to use a method called slide divide bottoms up, but I've seen other teachers teach like a box method or guess and check or whatever. So if you don't like slide divide bottoms up, you are welcome to look up online and remember how to do these using other methods, box method. Khan Academy is a really good resource, KHAN, if you look that up. And then I also have some other videos on my webpage of the other ways to do it if you look back at my Math 3 units and at my pre-calc units. So slide divide bottoms up. The first step is slide. So 3 times 2, the 3 slides over to the 2 and that gives me a 6. And then I've got a negative 5. So I'm looking for two numbers that multiply to 6 and add to negative 5. And that'd be negative 3 and negative 2. And so those are the numbers that are going to end up in my parentheses. So that was the slide step. The divide step is to go back and divide each of these numbers by 3. And I'm dividing by 3 because that's the number that I slid to start with. So I simplify those fractions if I can, so x minus 1. And then if it can't be simplified, or if I simplify it and it is still a fraction, then I move the bottom up to the front. So 3x minus 2. So that was slide, divide, bottoms up. I make sure if I have a GCF, I go ahead and bring that back down. So again, I have 3 solutions, 0, 1, and positive 2/3. And then comes up. All right, example 3, 8x to the third minus 1 equals 0. So this one is actually the difference of cubes, which you probably haven't seen a lot of. It doesn't show up all that often, to be honest, but I wouldn't want to not review it and then have it show up. So, difference of cubes. If you look at the page in your packet, I kind of gave you the little formula for factoring it here. So you have to figure out, you have something cubed plus or minus something cubed, and you have to figure out what those things are first. And then once you know what they are, then you can kind of follow this formula. So when I look at this problem, if I have if I have 8 times x cubed, that means I have 2x to the third, 2x times 2x times 2x, and then that's minus 1 to the third. And so there's my first term, there's my second term. We're doing the one that's a minus. And so if I follow this pattern, I can see that the minus here will stay a minus in the first set of parentheses, and then here it will be a plus, and then over there it's always a plus. There's a little acronym to remember that. We say that this one is the same sign, this one is the opposite sign, and this one is always positive. So you just have to remember SOAP. Alright, so if I follow the pattern, I have the first term, same sign, second term, and then I have the first term squared, so 2x times 2x is 4x squared, and then opposite sign, and then first term times second term, and then always positive, and then last term squared. So over here I know that this equals 1/2. That's pretty easy. This part over here, you could try to factor it. It's typically not factorable, and it typically gives you a complex answer, so that means it's like imaginary. So the only way to really tell is to use the quadratic formula on it. The nice thing about calculus is we don't do a lot of focus on complex answers or imaginary numbers. We typically work with real ones. And that's not to say you can never use calculus with imaginary, it just means that it's not a focus of our class. So I'm going to do the quadratic formula, and if I can see that it's going to be an imaginary number, I don't have to keep going, I can just stop. So first I have negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. And I'm going to stop right here because this is 4 and this is 16. And 4 minus 16 is a negative. That means that's going to give me an imaginary number, and so I'm done. And then one last example. We are not going to solve this problem because we won't have enough information to solve it, but I did want you to see how to factor it. So this is factor by grouping. I can tell because it's 4 terms, and I can see like, oh, a lot of those terms kind of have something in common. Factor by grouping, I would say, is really common in calculus, but in like funky situations. So this would be like overly simplistic for factor by grouping for us, but at least you'll see a few of them before we see them in calculus. So what I do with factor by grouping is I kind of break the problem into 2 halves, and then I look at each half and I take the GCF out of that half. So the GCF over here is x, and then the GCF over here is y. And it was kind of convenient that the halves, that I could just break the first 2 terms and the second 2 terms, and kind of worked out. Sometimes in grouping problems you do have to switch the terms around to make it work, but in this case we were good. So now I basically have 2 terms. I have this big group over here and this big group over here. And what I can see now is that I have a GCF. And the GCF is actually the whole parenthesis, that it shows up in the first term and it shows up in the second term. So I'm going to go ahead and write that whole parenthesis. And then I'm going to write my leftovers, because this is like me taking a GCF out. When I divide that out, I have an x left over, and I have a positive y left over. Now, this is actually not done being factored because this is difference of squares. So I'm going to go ahead and factor this part. So for this answer, I could leave it like this, or I could condense it down and say the x plus y factors being squared. Whatever you do is totally fine.